For this particular polynomial, they want us to graph it. So one of the first things that you're going to notice is that your degree of your polynomial is even. So my degree is even, and my leading coefficient is 1, which is positive. And the reason that's important, because that's going to determine my end behavior. So this one, since it's even, it's going to, both left and right side are going to go up. So it's going to look something like this, with both the left and the right going up. It's also going to mean, since the degree is 4, that it's going to have 4 possible roots. So it says find the roots. So what we're going to do is we're going to factor by grouping. So we're going to group the first 2 and the last 2. So for the first grouping, my leading coefficient, or my greatest common factor, is going to be x cubed. So I'm going to factor that out. For the second grouping, I'm going to factor out a negative x. So one of the things for this one, we're going to do a little bit of a change here. We're going to change the 3x to a negative. So that way this is going to change. So this is going to be x minus 3. And the reason it's negative 3 instead of the positive 3 how I had it is because if you distribute back your negative, negative times negative makes it a positive. So we're going to go ahead and change this to a negative. So that's going to become x minus 3. Otherwise we wouldn't be able to factor it by grouping. So now notice the x minus 3's are the same. So we're going to go ahead and factor that. And then we're left with x cubed minus x. We're going to set that equal to 0. So we're going to have x minus 3 equals to 0. So one of my zeros, or roots, are going to be x equals to 3. The other one, I have x minus x equals to 0. So I'm going to be able to factor out another x. So I'm going to have x equals to 0, and x squared is equal to 0, or x squared is equal to 1. And if I take the square root of both sides, I get plus or minus the square root of 1, which is just 1. And don't forget, you always get you need your plus or minuses. So those are my roots, 3, 0, plus or minus 1. So that's what I'm going to graph. So I'm going to graph 3, 0, positive 1, and negative 1. And I also know that my behavior looks like this. The next question says use synthetic division to find where x equals to 2 is. So we're going to put the 2 here. And we're going to put our coefficients. We need to make sure we have all our coefficients. So we have 1, negative 3, negative 1, and 3. And notice that we are missing our constant term for our coefficients. So we have 1, negative 3. Remember we changed that. Negative 1, 3. And notice we're missing our constant term. So we're going to add a 0 for our constant term. We're going to bring down the 1. We're going to multiply 2 times 1. And we're going to put it here. So that's going to be 2. Negative 3 plus 2 is negative 1. 2 times negative 1 is negative 2. Negative 1 minus 2 is negative 3. 2 times negative 3 is negative 6. And 3 minus 6 is negative 3. 2 times negative 3 is negative 6. And 0 plus negative 6 is negative 6. So when x equals to 2, y equals to negative 6. So that's another point I'm going to graph. So when x equals to 2, y is negative 6. So I'm going to use these 5 points to graph my graph. So it's going to start up. It's going to go down, up, down, and then up again. So that's a possible way that my graph can look like. Part D says describe the end behavior. So as x goes to the left, right, that's what negative infinity means. As x goes to the left, the y value is going up. So it's also going to infinity. As x goes to the right, my y value is going up. So it's also going to infinity.